In mechanical engineering, there is one diagram that decides whether a structure survives or fails. Bridges, pressure vessels, aircraft wings, bolts, welds, all are designed using one curve. That curve is the stress-strain diagram. You will understand it from zero to mastery, not just theory, but real engineering meaning. Before the diagram, we need two basic ideas. Stress is force applied per unit area. Strain is deformation divided by original length. Stress tells us how hard we pull or push. Strain tells us how much the material stretches or compresses. When we slowly pull a material in record stress on one side and strain on the other, we get a stress-strain curve. This curve tells us how strong the material is, how flexible it is, when it will permanently deform, and when it will finally break. Let's look at the complete stress-strain diagram. X-axis shows strain, Y-axis shows stress. The curve has 5 critical regions: elastic region, yielding, plastic deformation, ultimate tensile strength, fracture. The proportional limit is where the curve stops being a straight line. The elastic limit is the maximum stress up to which material fully recovers. Beyond elastic limit, damage becomes permanent. Now comes the most dangerous zone, yielding. At yield point, material starts deforming without increase in stress. In mild steel, we see upper yield point and lower yield point. Beyond yield point, the material enters plastic deformation. Here, shape does not recover. Atoms permanently rearrange. Cross-section starts reducing. This region is critical for forming operations like rolling, forging, bending, welding. Residual stress. The highest point on the curve is ultimate tensile strength. This is the maximum stress the material can withstand. Beyond UTS, necking accelerates and failure is unavoidable. Finally, fracture. The material breaks into two pieces. Ductile materials show cup and cone fracture. Brittle materials break suddenly with almost no plastic deformation. Ductile materials like steel have long plastic regions. Brittle materials like cast iron fracture almost immediately after elastic limit. That's why brittle failure is extremely dangerous. Engineers use this diagram to design pressure vessels, select welding parameters, choose safe load limits, prevent catastrophic failures. Every safe structure begins with understanding this curve. If you truly understand the stress-strain diagram, you understand how materials behave under load. Like the video if it helped, subscribe for more engineering clarity, and comment what topic you want next.